Here we have another u-substitution example problem, and we want to solve the following integral using u-substitution. So when we look at this integral, we can see that it's a little bit different than integrals that we've solved in the past. We have a term on the left-hand side, and we have another term on the right-hand side. And if we don't know how to evaluate this integral, it can look a little bit overwhelming. And so the first step in solving this example problem is we want to split up our integral. And so what that means is we can solve the integral of the first portion and then add it to the integral of the second portion. And we're able to split this integral up because we have an addition sign that separates the two terms. If these two terms were multiplied together, we wouldn't be able to split up the integral as you can see here. So after we've split up the integral, we can go ahead and solve each integral separately. So the first integral, we can see that we have a term x multiplied by another term, cosine of x squared plus 1. And so we know that this is probably a good candidate for u-substitution. And so we're going to go ahead and use u-substitution where our u is going to be x squared plus 1. Our du will be equal to 2x dx. And then we can go ahead and simplify this where we'll have 1/2 du is equal to x dx. And now that we have our u terms and our du terms, we can back substitute into our original example, and we can replace this term with our u and du. And so we'll have 1/2 cosine of u du for our integral. And after solving this integral, we'll be left with 1/2 sine x squared plus 1 plus c. And you can see all we did for this u term was we input our u that we previously defined. And so we have this left-hand integral solved, and then we can go ahead and look at the right term integral. And so we know that when we look at this, this is really just a inverse tangent solution. So this is just a integration rule. We know that when we see 1 over x squared plus 1, that we know it's tangent or the inverse tangent of x. So we can go ahead and that's a quick solution. And after we have both our left hand and right hand terms, we can go ahead and combine them to get our solution for this example.